Hi, I'm here to review the geometric principles we've learned so far. My name is Chris Lindberg and I'm an instructor at Shoreline Community College. This is the diagram we're asked to solve. We're solving for angles 1 through 10, and we're given the following information: that A and C are tangent points, arc AHC is 124 degrees, CD is the diameter, arc EFC is 136 degrees, arc HC is 40 degrees, and arc EF is 62 degrees. This is all very complicated, and by simplifying and just looking at parts of this diagram, I think we'll do a little bit better. Let's start with angles 1 and 2. They've told us that A and C are tangent points. Principle 15 tells us that a tangent is perpendicular to the radius at its tangent point. If arc AHC is 124 degrees, and principle 16 tells us that the angle formed by two tangents is bisected by the line BO, the line to the center of the circle, and that it cuts the arc in half as well. So the 124 degrees divided by 2 is 62 degrees. Principle 18 tells us that a central angle is equal to its intercepted arc, so angle 2 is equal to 62 degrees. Principle number 6 tells us that the sum of the three angles in the triangle any triangle equals 180 degrees. So angle 1 will be 90 degrees minus 62 degrees, or 28 degrees. Now we have the solutions for angles 1 and 2. Angle 1 was 28 degrees, angle 2 was 62 degrees. Let's go on and look at some of the other areas. Don't forget the chord CD is the diameter, and arc EFC is 136 degrees. Arc HC is 40 degrees, and arc EF is 62 degrees. We'll need the information to solve for angle 3. Principle number 20 states that an angle formed at a point outside a circle by two secants, two tangents, or a secant and a tangent, which is what we have in this case, is equal to half the difference of the intercepted arcs. So it means we've got half the difference between arc CF, which we don't know at the moment, and arc HC, which we do know. We can figure out arc CF by subtracting arc EF from arc EFC. So putting in 136 degrees and subtracting 62 degrees, we find that arc CF is 74 degrees. Now we can solve for angle 3. Angle 3 is 74 degrees minus 40 degrees divided by 2. 74 minus 40 is 34 degrees divided by 2 is 17 degrees. So angle 3 is 17 degrees. Now remember that angle 16 told us that line BO bisected the angle there at B, which means that angle 3 plus angle 4 have to equal angle 1, which was 28 degrees, or angle 4 equals 28 degrees minus angle 3. Angle 3 was 17, so we substitute in the value, and angle 4 is 11 degrees. Now let's take a look at angle 5. Principle 18 states that an angle formed by two chords that intersect inside a circle is equal to 1/2 the sum of its intersected arcs. So on one side of angle 5 we have an intercepted arc of 74 degrees. On the other side we don't have that information yet, but by adding 136 degrees plus 40 degrees, Subtracting that from 360 degrees, we find that we have 360 minus 176. It's 184 degrees. So adding together 184 degrees, which is what we have on one side, and 74 on the other side, we find that we have 258 degrees total. Dividing by 2, we get angle 5, which is 129 degrees. Let's look at the rest of our diagram. Now let's look at angle 6. Principle 18 states that an inscribed angle is equal to 1/2 of its intercepted arc. An inscribed angle is an angle that has all 3 points within the circle, on the edges of the circle, such as angle 6. Now to figure out arc DE, we're going to subtract the 136, which is arc CE, from 180 degrees, which is arc CD, which is a diameter. So subtracting the two, we get 44 degrees for arc DE. And via principle 18, we divide that by 2 and find that angle 6 is 22 degrees. Now angle 7 also is an inscribed angle, intercepting 74 degrees. So angle 7 is half of 74 degrees, or 37 degrees. Angle 8 is also inscribed, even though we extended one of the arms beyond the circle. And it intercepts a 40-degree arc, so half of it is 20 degrees. Finally, angle 9 is also an intercepted arc. And if we take 180 degrees and subtract the 40 degrees, which is arc HC, from it, we'll have what angle 9 intersects, or 140 degrees. Divided by 2, angle 9 is 70 degrees. And principle 18 also states that an angle formed by two chords that intersect is half the sum of the two intersected arcs. Now angle 10 intersects an arc of 62 degrees on one side and intersects the diameter at the other, or 180 degrees. So we add 62 plus 180 and divide that by 2, or 242 divided by 2, giving us 121 degrees. So that's the solution to our problem. Now we have all the angles 1 through 10. It looked difficult to begin with, but with all our information and the principles we learned, it wasn't so bad after all. I hope you enjoyed this lesson. Bye.